Hello, folks. So far we've looked at 4 theorems on circles, right? Some of those related to chords, angles subtended by the chords, the properties of arc, so on and so forth. So that's where we stand. If you think there's too much going on, you can always pause and refer to the mind map that we have built incrementally. It's on our site. Otherwise, we can move on, right? Just when you think you're done with something, it's the beginning of a new thing, just like any point on the circle. Cool? Okay, let's continue with our journey. Today, we'll talk about theorems on arcs. Okay, so let's say we have we're going to look at the central angle, which is the angle subtended by an arc at the center, and what is its relationship with the angle subtended by the same arc anywhere else on the circumference. Okay, too many words, but let's pause there and let's look at the diagram and the shape. So here's an arc AB. Okay, so I've just joined the points to the center. So the central angle in this case is AOB, right guys? Central angle of arc AB is nothing but angle AOB, okay? Now let's say there is a point P on the circumference of the circle that is not on the arc, okay? So I'm not talking about any point here or here or here, because all these points, let's call them, let's say this is S, this is T, and this is U. All these points lie on the arc, but I choose to pick a point that does not lie on the arc, AB. Okay, so hence I've picked a point P that is not on the arc, but it's on the circumference of the circle. Okay, so what we are interested in is to find what is the measure of angle APB, in relation to the central angle. Okay, fine, let's find that out. To do that, let's draw a line, okay, or rather I should say it's a ray, right? One endpoint is at P, but this ray passes through the center of the circle. Oops, sorry. It passes through the center of the circle. Let's call this ray, I'll have a point D here, okay? So I'm picking a point D on this ray. Let's look at PD. Now, by joining this line, you clearly see that there are two triangles, triangle AOP and triangle BOP, right guys? It is these two triangles. One is this, I'm just filling it up, and the other is this. Okay, now, what are all the things that you can observe on this diagram? Clearly, OA is the radius, OP is another radius, OB is another radius. So triangle AOP and triangle BOP, right, are isosceles triangles. Right guys, in which case if two sides are equal, the angles opposite to them are also equal. So let's say we have this angle here and this angle. These two angles are equal. Okay, let me choose another color. Similarly, we have this angle, and this angle are equal. Right guys, so let's just note that down. If I were to call this small angle X, okay, then this is also X. Whereas if I call angle OPB Y, then angle OBP is also Y. So if we put them together, we have angle OPA is equal to angle OAP is equal to X and angle OPB is equal to angle OBB, which is Y. Cool. Now, we are interested in finding angle APB, the measure of APB, in relation to the central angle AOB. Okay, so let's find that out. Now look at triangle AOP, guys, right? For the triangle AOP, what do you think is the angle AOD? This angle. What do you think that is? This angle, don't you think, is the exterior angle to this triangle? Okay, AOD is an exterior angle to triangle AOP, which means what? The exterior angle is equal to sum of its interior opposite angles, right? So it is a 2x. Clear? Similarly, for triangle POB or BOP, you can observe that angle BOD is an exterior angle, which means the measure of this is going to be the sum of interior opposite angles, right? So when you write this, you definitely have to write the reason. Let me make some space quickly. Okay, so the reason for both these statements to hold true is that the exterior angle is equal to sum of its interior opposite angle. Interior opposite angle. Cool, they're in two different triangles. So can I write this as 2x and can I write this to be 2y? So knowing this, what is the measure of the central angle, which is AOP? Isn't this equal to 2x plus 2y? Or when 2 is taken common out, you get 2 into x plus y, right? In the meantime, what is the measure of angle APB? It is, as you can see in the diagram here, right, this one, APB is an x plus y. So clearly, when you compare these two equations, right, you will see that one is twice the other. So the central angle, okay guys, central angle is twice angle APB. So just to conclude this theorem, the angle subtended by an arc at the center is, okay, twice the angle subtended by the same arc anywhere else on the circumference. Okay, so I request you to just pause the video and go through the proof. It is very simple. Subtended, or there's some, sorry, the spelling is wrong. This is supposed to be subtended by the same arc anywhere else. Okay, very simple. So let's move on. Now, if you have to apply this, right, look at the first circle. We have arc AB. In this case, clearly, let's say I'm talking about the minor arc, this portion of the arc, the minor arc AB. And if I pick a point somewhere here on the circumference that does not lie on the arc, let's say I call that C. If I told you this were 56 degrees, okay, the measure of angle AOB is 56. What do you think is the measure of the angle ACB? It's 28, right guys? So angle ACB is half of angle AOB, or in other words, angle AOB is twice angle ACB. Okay, so all you have to note here is that you have this point, the end points of the angle is the arc. Okay, O is the center, O is the center, so the central angle is twice the angle subtended by anywhere else. Okay, easy. Now this is, you know, this is what you've just learned. Let me just erase all the ink. So it's not only for point C, guys. Now, supposing I picked another point on the circumference. Let's say this is D. Even that is going to be, if this were 56, right? This is 28. This is also 28. Even another point, let's say I pick a point E, even this is going to be 28. Cool? Fine. Now let's look at the circle, the second circle. Here, now I'm talking about the arc PQ. In this case, I'm interested to know, look, when we talk about a central angle of an arc, the central angle can be that of the minor arc or the major arc, right, guys? In this case, what if I'm talking about the central angle of the major arc, which is clearly a reflex angle, right? So if this is the case, such is the case, then what is the relationship between the central angle and the angle subtended, let's say, at some point that is not on the arc, but somewhere else on the circumference? Okay, shall we try and figure the same thing? Cool. Okay, so here we have an arc AB. It is, you know, we're talking about the major arc AB. Okay, so this is a reflex angle. And we've picked a point P. We've picked a point P that is not on the major arc AB. So P is somewhere here. Now let's try and prove and find out if the same relationship holds. Okay, so we join AP and PB, and we also draw a ray from P passing through the center of the circle. Okay, so let's figure this out. Again, let's mark whatever is equal, right, guys? I'll call this point D. So OP is OP, OA, and OP are radii as usual. Can you see that? Okay. So again, triangle AOP and triangle BOP are isosceles. It is actually the same proof, folks. You know, everything else remains the same. You just have to visualize it in a different way. So we have, if it's isosceles, we have this angle is equal to this angle out here. Okay. And in the other triangle, we have angle OPB. Oops. Making it very shabby, is equal to angle OBB. Okay. So now if this were Y, this is also Y. If the other were X out here, this is also X. So what can you say about angle AOD, right? This is definitely 2x because, folks, it's the same thing. It's still an exterior angle to triangle AOP. There's nothing new here. Am I right? Correct? And angle POD is a 2y, twice y. Same reason, but this time it's an exterior angle to triangle BOP. So if I were to write that down here, this is a 2x, this is a 2y. So the central angle of major arc, that's the only difference, of major arc AB is actually 2x plus 2y, or 2 of x plus y. What is x plus y, folks? It's nothing but angle APB. B. So it's whether it is the angle subtended by the major arc or the minor arc, it is always, the central angle is always twice the angle subtended by the same arc anywhere else, okay, on the circumference. When you say anywhere else, it's kind of implied that we're talking about a point on the circumference. So we stop it at that. We just use the word anywhere else on the circumference of the circle. Okay, are you all following so far? Fantastic. Now let's quickly look at a sample arc here. So we have SOR. If I told you this is a 60, then what do you think is the angle RTS? Okay, it's not on the arc, it's somewhere else on the circumference. So this is clearly half of 60, which is 30. We have another case where we have major arc SR. I'm now talking about the major arc SR, not the minor arc, okay? And if I told you this angle were a 220, how much is it, guys? 220 degrees. Then if I chose a point T that is not on the major arc but elsewhere, what do you think is the measure of angle STR? This is also going to be half of the central angle. So it's clearly 110. Are we all good with this? Okay. So let's take a pause here and then continue with, as an extension, as an outcome of what we've just learned about the central angle, we'll see what's going to happen to angles in a semicircle. Cool? Okay.